Welcome to this overview of the pregnancy and parturition in the cow. In this video, we will globally explain the processes involved in making a calf. The reproductive organs of the cow are located in the caudal part of the abdomen, ventral to the rectum, and consist of the vulva, visible from the exterior, the vestibulum, the vagina, the cervix, which forms the barrier between the uterus and the outside world, the uterus, which is bicornuate and consists of a corpus and two cornua, the oviduct, comprising the infundibulum, ampulla, and isthmus, and the ovaries, which produce the follicles. The hypothalamus produces GnRH, which stimulates the pituitary to produce LH, luteinizing hormone, and FSH, follicle-stimulating hormone. LH and FSH, in turn, stimulate the ovaries to produce estradiol. When the estradiol concentration reaches a certain threshold, it leads to a peak in LH from the pituitary, also called the LH surge. This LH surge, in turn, causes ovulation. This marks the follicular phase. The ovulatory follicle then becomes a corpus luteum, which produces progesterone. Progesterone exerts a negative feedback on the hypothalamus and pituitary, suppressing the production of GnRH, LH, and FSH. This is known as the luteal phase. The estrous cycle of the cow lasts for 21 days. The follicular phase is 5 days long, and the luteal phase is 16 days long. In simplified form, the hormones fluctuate as follows. During the follicular phase, FSH peaks, stimulating the follicular growth. It then decreases and remains low during the luteal phase. LH rises significantly during the follicular phase, allowing the follicle to develop to its pre-ovulatory state. At the end of the follicular phase, LH surges, causing ovulation, before dropping and remaining low in the luteal phase. Estradiol increases throughout the follicular phase due to the growth of the follicles, and also drops and remains low during the luteal phase. After ovulation, the corpus luteum produces progesterone, which increases as the corpus luteum grows. After a few days, it reaches a maximum. As the follicular phase commences, PGF2-alpha produced by the endometrium causes luteolysis, leading to a decrease in progesterone. Estradiol is the hormone responsible for the sexual receptivity of the cow. The period in which the cow is receptive or in heat is called estrus, and this is also the time during which she is fertile. It is caused by high levels of estradiol and low levels of progesterone. Signs that the cow is in heat are restlessness, increased activity, mooing, phlegmon, smelling and licking the vulvas of other cows, mounting and standing to be mounted, swishing and lifting of the tail, swelling of the vulva, and mucus discharge from the vulva. When the cow displays the signs of being in heat, she can be inseminated within a few hours. The sperm is inserted into the uterus under rectal guidance. Half the sperm is deposited into the right horn and half into the left horn. Sperm travels through the uterus towards the oviduct, passing through the isthmus to the ampulla. The traveling is achieved by the movements of the sperm's tail and by the contractions of the uterus. Meanwhile, the oocyte leaves the ovary, passes through the infundibulum, and meets the spermatozoa in the ampulla, where fertilization takes place. The oocyte and spermatozoon fuse, forming a zygote. The zygote is a single 2N diploid cell. The zygote undergoes a series of mitotic divisions called cleavage divisions, in which the total amount of cytoplasm remains the same. This yields 2, 4, 8, 16, and 32 daughter cells. When the individual cells, also called blastomeres, can no longer be counted accurately, the early embryo is called a morula. The outer cells then become more compacted than the inner cells, and eventually a blastula, or early blastocyst, is formed. The blastula consists of an outer layer of cells surrounding an inner, fluid-filled cavity called the blastocele. The outermost layer of cells is called the trophectoderm, and the inner cells develop into a mass of cells called the inner cell mass. The inner cell mass will later develop into the body of the embryo, and the trophectoderm develops into the chorion, or fetal component of the placenta. In the cow, the trophectoderm elongates significantly. The trophectoderm produces bovine interferon tau. Due to the elongation, a large amount of interferon tau is produced. This protein inhibits the production of prostaglandin F2 alpha from the uterus, preventing luteolysis. Without luteolysis, progesterone remains elevated, inhibiting the new cycle and allowing the pregnancy to continue. The process of maternal recognition is highly species-specific. Trophectoderm or trophoblast forms the outer layer of the conceptus, and the inner cell mass develops into the embryo proper. A layer of cells develops beneath the inner cell mass and forms a lining on the inside of the trophectoderm. This lining is the primitive endoderm. At the same time, the mesoderm begins to develop between the primitive endoderm and the embryo. When the primitive endoderm completes its growth, it forms a cavity called a yolk sac. The mesoderm continues to grow, forming a sac that surrounds the yolk sac and pushes against the trophectoderm. This folds upwards, forming wing-like structures called amniotic folds. A diverticulum, called the allantois, also develops from the primitive gut. The yolk sac regresses and the allantois grows. The amniotic folds fuse, creating the chorion and amnion. These are composed of mesoderm and trophectoderm. The amnion creates the amnion cavity. The allantois and chorion fuse, creating the allantochorion. This consists of endoderm, 2 layers of mesoderm, and trophectoderm. Gestation in the cow lasts for about 280 days. Pregnancy can be diagnosed using multiple methods. Here you can see the methods along with the times during which they can be applied. The methods include rectal examination, where one can feel the corpus luteum graviditatis, the asymmetry of the cornua of the uterus, the fluctuation of fluids, the membrane slip, the amnion sac, the fetus itself, the placentomes, and the Gefäßschwere. In addition to rectal palpation, the calf can be felt externally through abdominal ballottement. Ultrasound can also be used transrectally, and pregnancy-associated glycoprotein can be measured in the blood. Signs that the cow is ready to give birth include restlessness, the sinking of the base of the tail, raising of the tail, clear mucus discharge, a swollen and loose vulva, edema of the udder, and filling of the udder with milk. When the fetus is mature enough to be born, it becomes stressed due to space limitations. This causes the calf to release cortisol, initiating a cascade of events that culminate in the birth of the calf and the expulsion of the fetal membranes. The fetal cortisol release causes the conversion of progesterone to estradiol. This causes myometrical contractions, increasing the pressure inside the uterus. This causes the calf to push against the cervix. As the calf is pushed into the cervical canal, it dilates the cervix. This causes abdominal muscle contractions, aiding in the expulsion of the fetus and the fetal membranes. The fetal cortisol also causes the placenta to synthesize PGF2 alpha, stimulates the myometrical contractions directly, and causes the regression of the corpus luteum and a decrease in progesterone, further stimulating myometrical contractions. The synthesis of PGF2 alpha also stimulates the synthesis of relaxin. Relaxin causes a softening of the connective tissue in the cervix and promotes elasticity of the pelvic ligaments. This causes the sinking of the base of the tail as seen in the signs of prodromy. The softening of the connective tissue aids in dilating the cervix and allowing the calf to enter the cervical canal, as well as the expulsion of the fetus. The conversion of progesterone to estradiol also caused the cervix and vagina to produce mucus, washing out the cervical seal of pregnancy and lubricating the cervical canal and the vagina. This also helps in the expulsion of the fetus. Furthermore, the abdominal muscle contractions lead to the rupture of the fetal membranes, which also lubricates the cervical canal and vagina. The dilation of the cervix and subsequent entry of the calf into the cervical canal causes an increase in pressure in the cervix and vagina, causing oxytocin release. Oxytocin acts to facilitate the myometrical contractility initiated by estradiol and PGF2 alpha. Stage 1 of parturition consists of the myometrial contractions and cervical dilation and lasts 2 to 6 hours. Stage 2 consists of the expulsion of the fetus and lasts 30 to 60 minutes. And stage 3 consists of the expulsion of the fetal membranes and lasts 4 to 6 hours. Then there was a calf. Things can go wrong during every stage of gestation, leading to resorption of the fetus, abortion, maceration, or mummification. If you want to know more about mummification, you can read our report. Special thanks to Bobby Roelofs. Thanks for watching!